like I already told you, Urbano project is everything is saved in your standard AutoCAD DWG file, but it's composed of the graphical part, which is the CAD drawing itself, and also Urbano internal model. And today I will show you how you can extract Urbano model from the DWG file, and so basically export it from one drawing and import it to another drawing. And that will be our first topic today. So here we have our water distribution network that we've been working on it for the past 2 days. And now I will also open one sewage network, which is created with also Urbano software, but Urbano Canalis, which is part of Urbano family. So let's open this drawing as well. So as you can see, separate DWG file. And here now I'm trying to simulate, for example, a project where one designer or one company was working on a water distribution network, and another designer or another company is designing the sewage system. So let's take a look. This is completely done project. We can check a little bit in plan. We can see this is a sewage network. We have all the pipes, all the manholes set. We have this really nice labels showing in plan, and we can see how this system looks like. Also, if we check the profiles, we can see the default configurations for the profiles. And here you can see that basically, notice these profiles, we have no intersections between other infrastructure, because here in this system we have only, here is the system selection, you can see that we have only the sewage system here. And now I will export this system from this DWG, and I will import it to our system where we have our water distribution network. And you will notice that all the model and all the profiles of both systems you will see that all the profiles will automatically update, and all the clashes and crossings will be automatically updated. So let's do this. So to export this, you have to go here to the function where you usually create a new system. And here you have a functions for importing topology and exporting topology to Urbano XML. With these functions, so be sure this is not a standard land XML file. We also have land XML. I will talk about this later. This is internal Urbano file format, so Urbano XML, which you can use to export from one drawing and import to another drawing. You can, with this function, you can export complete networks, so sewage, water, and other pipe infrastructure. You can also export Urbano Terraform DTM surfaces and also Urbano parcels as well. So let's go to export topology to Urbano XML, and I will define where I would like to export this. Let's go here to this same folder where we have our water system. Let's click Save. Okay, this system will be exported, and let's just click Export. And this is quick. You see file is written. Let's now close this drawing. I don't need it anymore because I would like to merge these projects here. And here I will again click on this icon here. And let's now go to import topology from Urbano XML. And let's search for this file. So here we are in day 3 Hydra, sewage network XML. Let's open it. This is the system, Novi Sewage, and let's click on import. And it will take maybe 10 seconds for this system to import, but it is important to say that we are importing complete Urbano model from the internal Urbano database. Like I said, we will have the plan, we will have the profiles, and we will have all the intersections, so crossings and clashes automatically calculated. So you see how the system perfectly positioned on the right coordinates in plan. And also here are the profiles from the sewage system. And what I told you before, look at this. So now the crossings between the systems have been automatically calculated. So this is something that is really impressive in Urbano software around the crossings and clashes. Everything is automatically calculated. So you don't have to worry about, for example, if you move some pipes, if you made some modifications, if you draw some additional parts of the network, you don't have to take care of this stuff, because the software is taking care about this instead. So look at this here. You see here, these are the clashes, and we see the distances between the pipes are 0. So of course, if we are here talking about a multi-designer workflow, and we have, for example, one guy doing water system, another guy doing, or company doing the water system, somebody should made some modifications. So let's now also zoom to our system that we designed these past 2 days, our water distribution network, and we also see how the profiles automatically updated, and we see the relative positions of these sewage pipes with all these details that of course can be set up in the profile configurations. Okay, so let's now analyze these crossings a little bit more. First of all, I will just turn off the layers of these labels, because we have too much of these labels now. So I will just go to CAD function for turning off the layers. And because each, like we learned the first day, each element of Urbano model is on its own layer. So I will just turn off these layers like this. Okay, and now we have the better look to our two networks. To analyze the crossings and the clashes between multiple networks, you can go to intersection analysis panel. So it's here, and here we can turn this on, and here you have many different functions where you can do all kinds of analysis for the intersections between different pipe infrastructure. The most important function is intersection preview. So if you open this, you will see that you have a detailed data table with all the data about the crossed infrastructure. And here you can see, for example, in different tabs. Michael, can you please maybe just mute yourself? I hear your, if it's not a problem. Okay, so okay, so here you can see in the data table, you have the elements. So in this case, these are the pipes. We see the system names. So we see that it's a water system and the sewage system. We see the names of the elements. So in this case, pipes. We see the data about those elements. So nominal diameters about the pipes. We see the relative positions of the pipes. So which pipe is above or below selected pipe. We also see the ones that are in direct collision. So these are the pipe clashes. And also, like I said, we see in different tabs, clashes or crossings between pipes and manholes with manholes. And if we just pick inside of the tables, we will automatically be zoomed to that crossing in plan, or also we can zoom to profile as well. And here you can see all these crossings. So between pipes, and also if I switch here to pipes and manholes, we can see that we have the clashes or crossings between pipes and the manholes. So like I said, of course, we would have to move something or edit some of this stuff. So let's do it. So first of all, we are doing our water distribution network. So let's switch here from the system selection panel. Let's switch from the sewage system to our water distribution network. Okay. And here we see that here we have these problems here. So I will just move this water manhole. And here we have the function on the Urbano ribbon, move node. And let's select this icon here. And I will just move this manhole. And for example, I will position it here. And like I said, everything is completely dynamic. So you see that the table is now empty. You have to just click again to select everything because we have some changes. And now you see that we have only one more clash between the pipes and the manholes, because here we solved multiple clashes at once. Let's zoom to this one here. And again, we see that we have the same problem. So let's again solve this part here. And I will do the same. I will take this node. Let's take it with the move node function. And let's move it, for example, here, like this. And now you see that the table is empty, but let's select one more time the whole system. And we see that we have no more problems, no more clashes between pipes and manholes, and also manholes with manholes is empty. But let's check pipes with pipes, and we see that we have some distances here. And let's now click here, show only collisions. So we can sort this data table by distances, and we also see that here is 0. So obviously here is a clash, but let's filter it out and let's click here, show only collisions. And here we see that even though we moved this node here, we still have a clash between these two pipes. Okay, so the thing that I would like to do now, I will draw one additional profile because I don't have a profile that goes from this node to this node, and I would like to see that profile. So let's start again function for drawing of the profiles. Let's use the function from node to node, and let's go from this node to this node here, and let's draw this profile here. Okay, and let's zoom. Okay, this is the problem. So as you can see, this is our water pipe and this is the imported sewage pipe. So we have to do some modifications. Of course, it would be better if we could go with the water system to go above this this sewage system. So let's do it. We can go to function for editing in the profiles, the function that I showed you the first day. So let's go to function, no, not this, but this, editing in the profile. And now we can select any part of the profile. For example, let's select from this point to this point. And now we can, for example, we see that the depth of the center line here is 2 meters. But let's put, let's say, 1.2. I think this should be enough. Let's click on preview. Okay, and now we can click apply. And now we see that everything is completely dynamic. Now we should see here some distance, and we see that now the distance between these pipes is almost 40 centimeters. So this is now solved. And we can also delete this profile because we don't need it. Let's now check the table. So let's go back to intersection panel, intersection preview, and let's now turn off this option because we see that it's filtered out to show only collisions. And now we can check and see that the minimum distance between any two pipes is 16 centimeters here. And we can see that here the first system in the list is water system and the second system is the sewage system. So this is the referent system. And now if we check this, we can see that almost everywhere, so above, so water system is always above the water system except for here. So here we see that the water system is below the sewage pipe. So maybe we can solve this as well. If we insist that the water pipe should always be above the sewage pipes. But let's not change this now. You know the procedure how this can be edited as well. Okay, so but you can zoom. For example, this is the problem here. Let's go to zoom to profile, and let's zoom, for example, to this water profile, V4. This is it. And now we can see, and here it is. Here is the issue. You can see that the sewage pipe is above our water pipe. Okay, let's now save this drawing, and I will save it as a different drawing so you can get all these working files. So let's call it Urbano Hydra working 3 as day 3. Okay, and now I would like to open another drawing, which is a really interested project where we have 4 different Urbano pipe infrastructure systems. So this is a real project, and you can see that on a relatively small area we have a lot of these pipe infrastructure systems. So you can see also in different colors and also in this legend that we have these 4 systems, and obviously we have a lot of pipe crossings in plan and potentially also a lot of pipe clashes. So let's analyze this system. First of all, let's draw the profiles. We are here in sanitary system. Here we have our profile configuration. Let's double click on it. I will select the entire sanitary system. According to array definition, I will define row and column spacing to be 20. Let's click on draw, and I will place these profiles here to this point. Okay, and let's now check it. So what I said before, all the crossings, all the clashes are automatically calculated, and if these labels, so these are basically labels, are turned on in your profile configuration, you will automatically see all the crossed systems in your profiles. Okay, I already draw the profiles for all other 3 systems, so not to be repetitive, I already draw them. So I will just switch to a layer state where I have all these profiles already drawn. Let's restore this, and now you can see for water system, drainage and storm system, we also have all these labels turned on and shown here. Also, if you want to see some kind of labels in plan about the cross systems, you can do it as well. So let's again switch to intersection analysis, and here you see intersection label definition, where you can define different label configurations. Here I previously defined 3 configurations. It's basically very easy to create them. Just go to add. I will just go to edit and show you. Basically, it looks like standard configurations for the labels, let's say for the nodes that I showed you during the previous sessions. And here you can see that you can define which data you would like to see in the intersection label. For example, here we will see the distances, terrain height, and pipe top depth. Okay, or for example, another configuration, here I see different data, for example, coordinates of the crossing in plan, terrain height, and array station. Okay, to apply the labels, we can go to intersection settings, and basically here you can just turn on automatic labeling and label definition. Let's check this one. This is just intersection point. Let's click OK. And now you can see that there is no data. It's just this block to show you that you have some intersection happening in plan. Or let's change it. Let's switch maybe to intersection with the data that I showed you before. And now you will see that we have the distances between the pipes. We have the terrain height at that point. And also we see the top pipe depth for each crossed pipe. But also, if you don't like to see the labels in plan, you can just easily turn off automatic labeling and you will not see the labels anymore. Let's now also check the data table that I showed you in the previous example. So intersection preview. And here you can see that you can, just like for any other data tables in Urbano, you can create these data table configurations. you can create them here. So intersection preview definition. So you can create new data configurations. You can select which data you would like to see, and they are listed in this configuration. So if we go to intersection preview, again, just like in the previous example, you see the tabs. So pipes with pipes, pipes with manholes, manholes with manholes. So in this case, we also have the crossing between the manholes. And like I said, you see which elements these are, which system these are, what are the names of those pipes, what are their data. In this case, we have nominal diameters, and this really important data about which pipe is above, below, or in direct collision. So if we go here to show only collisions, we can see only collisions here, but also here you can see the collision by default is if the distance between the elements is 0 or less. But for example, let's define the collision tolerance to be 10 centimeters, which means that everything that is on a distance 10 centimeters or smaller will be treated as collision. So just click enter, and now you can see that we have here filtered the elements that are either in direct collision, or we have the distance between these elements 10 centimeters or less. So really nice option. And also, let's turn off now this showing only collisions. Let's check this filtering options. So this is really nice option, because if you have a lot of systems and a big area, and you would like to focus just on some part of the network. For example, let's check only the crossings and clashes here in this part of the network. I will go to selection, and I will select with, for example, CAD selection, just this part of the systems here. Okay, I will turn off now auto zoom option, and we can check and see these crossings or clashes. So we can focus just on some parts of the network. Or for example, let's select one array of the network. And for example, I'm interested in this sanitary sewage channel, this channel FK 1.5. So let's select it. And now you see we have all the crossings with that one array. Also, what is really important to say, that these crossings and clashes shown in this data table are not just some randomly selected crossings. That's why I would like to show you this intersection preview data table too, where I also have the data about the stations. So the first system that I selected is sanitary system, as you can see here, and these are the stations, the changes of that selected array. And now you can see that the crossings are sorted by stations. So this is the 7.68 meters from the start of that selected array, and they are sorted by stations. So this is really important and useful if you want to make some kind of reporting. And you already know this is just like any other Urbano data table. So you can select it, you can copy it, or copy it as HTML and paste it to Excel. Also, let's turn off this filter. If we go to pipes with manholes and, for example, turn on auto zoom, we see the crossings or clashes between them. And the same is with manholes with manholes. This is the case that we didn't have in the previous example. Okay, and also let's go back to pipes with pipes. It is important to say that these distances between the elements are calculated in 3D. So we can turn on this 3D style or 3D view, and even though our elements are not drawn in 3D, these are plain AutoCAD lines and or blocks. In this case, we have the realistic 2D style for these pipes and manholes. But let's switch to 3D view, and we turned on this showing of 3D. And let's now zoom, for example, to these elements here. And you can see that the software is automatically drawing 3D representation of these selected elements. and the distance is calculated in 3D. This is the shortest distance. So this line, as you can see here, let's select it and open it in properties. You can see that the length of this line is 2.74, which is the distance shown here in the data table. So that's how the distances are calculated between the pipes. So these are the real distances in 3D. Of course, if you need the vertical distance, you can get that value as well. But this is the shortest distance between the elements in 3D. So you can see also for distances between pipes and manholes, and also manholes with manholes. Okay, let's now turn off drawing of 3D. Let's go back to pipes with pipes, and let's close this data table, and let's go back to plan view. Now I would like to focus on the dynamics. I already told you before that you don't have to worry about this stuff. The software is doing everything. And now I would like to show you that. For example, let's say that we have these 4 systems that are existing, and we are designing a new system now. So let's switch here from the system selection to new system. Okay, we are here in the new system. And also here I prepared some helping points. This is a layer state with helping points. And this is the route for our new system. Let's say we have to design this new system. Let's click on draw network elements. And here I will set up some of the options. For example, we will automatically set terrain elevations from DTM. In this case here, we have terraform surface. As you can see here, this is the terraform DTM surface. So I will use that surface. Let's select it. So not Civil 3D, but terraform. We will, of course, draw the additional points. And also I will automatically define the pipe. Let's say I will use the water pipe, PEHD, with the nominal pressure 10, and pipe will be 110 nominal diameter. And I will say that the invert position or the pipe position, and now, as you can see here, I will not say axis, I will say the top outer point of a pipe will be 1.5 meters. So pipe crown will be 1.5 meter below the terrain, or let's put a little bit less, 1 meter. Okay, and let's now click draw. Again, I will use AutoCAD OSNAP to just connect to these circles. And notice now how the terrain heights in this tooltip are automatically read from the selected DTM surface, and all the crossings and clashes are being automatically calculated in the background by the software. Let's click right mouse button to conclude the drawing. And let's now draw the profile for that newly designed part of a network or newly designed system. I will select the whole system because we have just one array, and let's draw it here to this point. Okay. And let's check now this profile. So basically, I didn't do anything special. I just draw a new part of the network. I placed the constant depth below terrain for the pipe crown to be 1 meter. I set the pipe, and you see that all the crossings and all the potential clashes are automatically calculated and shown here. You see the distances, the terrain heights, and the intersection point stations, or any other data that you would like to add to this profile tables. And let's now check the dynamics. So let's now, here I prepared one viewport so we can simultaneously see both plan and profile. So let's zoom to this part here, which is this part here in plan. And again, from the ribbon, I will use the move node function. And now notice I will be moving the nodes in plan, and notice on the right how this will automatically update. So let's select, for example, this node here, and I will move it here. Notice how the old crossings will disappear from the profile and new ones will appear. So let's check it. Now you see it's a purple one, then blue, then purple, then green. Let's move it here now, and we will have a lot more crossings now. So you can see first we are crossing the orange, then the purple, then green, again green, purple, blue, blue, purple, green. So completely dynamic model. Let's bring it back here, and everything is automatically updating. And it's not just that this profile of this system that I'm moving is updating. Let's now check all the other profiles of all the other networks. Again, I have one predefined viewport, and also I will switch to a different layer state. So now we have this helping frames here, just showing you to focus on this system. So this is our new system, and we see first, this is the profile of the blue system, which is water system. Then we have the orange, which is the storm system. And then we have the magenta one, the purple one, that is the sanitary system. And I will be moving my new system, and notice how the other profiles will automatically update as well. So let's move, for example, this node here. You see on the right, everything is updating. And let's move this one. And for example, let's place it here. So now we have no crossings in these two profiles. And if I move it, for example, here, you will see that the crossings are back on. Okay, let's now turn off these helping frames. I don't need them anymore. And let's go back to having just one viewport. And as you can see, we have all the time, by default, the software is analyzing all systems with all systems. But let's say that we would like to analyze just my newly designed system with all others. So let's say that all the existing 4 systems are built, and we have no problems, we have no clashes between them. So let's now create something that we call a clash test. So let's go to intersection analysis. Let's go to system selection, and you can see by default is all entities, so everything with everything. But let's create new test, and let's call it new versus all other. And let's set this as a current test. And now on the left, I will select just my new system, and on the right, I will select everything. And let's click OK. On the first site, nothing changed because we didn't refreshed or updated anything. But let's now do this. I will go to the function that we call profile manager or longitudinal section manager. Let's open it. And here you can see that you can do many different things with the profiles. We'll talk about this later. But what I would like to show is that you can, if you select here all the valid, so basically all the profiles in all 4 systems, we can select all of them, and I will just redraw them. So when you redraw the profiles, you will see that all other crossings here will disappear, because as you can see, so everything disappeared except for the crossings with our new system. So that is a cool feature if you would like to focus just on your system and all other systems. For example, if we go to our profile of the newly designed network, you see the crossings between all the systems. So all the systems crossing our system, but in other profiles, we see only the new system. And it's not just about the profiles. Let's also go to our data table, intersection preview here. And now here you can see that we have only 12 crossings. We can also go to intersection preview number 2, where we have the stations. I will turn off auto zoom, and now you can see again they are sorted by stations, and we see just the infrastructure that is crossed with our newly designed system, and everything is sorted by stations. Also, if you need the labels, so let's now go to intersection settings. Let's turn on automatic labeling, for example, with this 3rd configuration with the positions. And here you can see that now we have coordinates, terrain height, and stations. And you can see that we have the labels just for the system that we are analyzing. So we don't have the labels for all systems, but just for the one system that we are analyzing with other systems. And like everything, the labels are also dynamic. Let's move, for example, again, this node. So node is 437.12 is the last station. Now it's 437.61. So the labels are dynamic as well. And of course, if you need some kind of reporting, which is, like I said already, you can just copy that data table. But if you need some report, you can go to reports. And here you can define, again, which data you would like to see in a report. And you can choose between Excel report or plain text file. Let's select the whole system. Let's write this report and let's open it directly in Excel. So as you can see, because we created a test, just our system with all others. So this is a new system. This is the array 13 because I didn't give some custom name. See the coordinates of the crossings or clashes, stations, terrain heights at the crossing point, which system is crossed, what is the nominal diameter, and what is the pipe top depth of the crossed pipe, and we see the distances between the pipes. Or you can also add any other data that you would like to see here. Okay, let's now close this table and let's save this drawing. We are done with this example. Let's save it so that you can have the end file as well. And I will call this, so for systems final. And let's click save. So we've been talking about crossings and clashes between different Urbano pipe infrastructure. But let's say that we do not have Urbano pipe infrastructure. We have just some CAD lines or polylines. Let's open our layer manager and let's turn on this layer, CAD infrastructure. So here you can see that we have some plain AutoCAD. In this case, this is line, and also this is 2D polyline. It can also be 3D polyline. And of course, what we can now do, we can create a new power system. We can convert these lines and polylines to intelligent Urbano topology. And of course, everything will be automatic and dynamic, and we could run intersection analysis. But let's say that we have a lot of these plain AutoCAD lines and polylines, and we don't know much about them. We just know this is some kind of infrastructure, some cables or something, and they are on a constant depth below terrain of, let's say, 0.5 meters. So instead of creating new systems, you can create something that we call groups of CAD elements. So let's go here. By default, one empty group is already created, but you can create also new groups. And I will rename this existing group to power. Okay. Here you have this familiar function for layer filtering. So you can just pick on a layer from the list, or you can pick on an item, on an element from plan. The software recognizes which layer this is. And now we can click, for example, if we want to filter the list, show just selected. Okay, and now I can freely select the entire drawing, and the software will select only the elements on selected layer. So these elements here. And now I can give this group a name, I already did, and I can select what pipe group from Urbano pipe catalog this will be. So let's say this will be some PEHD pipes. Pipe will be, let's put small pipe, for example, 110. And now it says, okay, but select the referent position of the pipe. And I will say, for example, axis of the pipe, or you can say, I don't know, top outer, so pipe crown or something, or bottom of the pipe. I will say axis of the pipe is on a constant depth. So if it's a 3D polyline, you can use CAD element elevation. But if it's a 2D polyline, you can use terrain elevation and define depth below terrain. We have defined 0.5. So 0.5 below the terrain. Okay, and that's it. So basically, we created a group. So this is now treated, we can treat it as, let's say, virtual Urbano system, because it's not a new system, but this is treated like any other pipes. We can, for example, use auto zoom and check on this element. So these are some kind of polylines, these are some kind of lines, and each element has defined the pipe group and the position of that pipe. Let's click OK. When we created the groups, nothing will automatically change in the profiles, but let's redraw the profiles. So I will go to, we are in the water system. Let's redraw it. Okay. And let's also switch to sewage system, and let's redraw the profiles. Or you can use, like I showed you before, the profile manager to redraw the profiles. And now notice how the orange crossings will automatically appear as well. So we have a power, nominal diameter of a pipe, and distance between these pipes. So this was the original Urbano topology, and this is the CAD element groups, but it's treated like any other pipes in Urbano. So this is the sewage system. And let's also check our water system. Our water system, and here it is, the crossings between the power cables and our newly designed water distribution network. This can be a lot helpful and really great functionality if you have a very big amount of such polylines that you don't need to convert to Urbano systems. Okay, and also if we go to our intersection preview table, let's check topology entity. You see these are the CAD elements now, and the system name is power. So let's use auto zoom, and this is it. You see the system name is power, and we have all the data, all the distances between the regular systems and groups of CAD elements as well.